Here we are starting the chapter Hyperbola. So let us start Hyperbola with introduction. What is Hyperbola? Hyperbola is a set of points such that the difference of its distance, means distance of point from two fixed points, is always constant. These two fixed points are called focus. Okay, so let us write the definition here. It is the set of all points in a plane whose difference of distances from two fixed points is always constant. And you see the diagram of hyperbola is like this. Here this is x-axis, x dash, this is y-axis, y dash, and this origin is called center of the hyperbola. And if P is any movable point here or set of points P such that the difference of its distances from two fixed points, suppose fixed points are here F1 and F2, then according to definition PF1 minus PF2 is always constant. So in this diagram we can say that PF1 minus PF2, this is always constant. Then this pair of curves, this is collectively known as a hyperbola, who is called center of hyperbola, and F1 and F2, these two fixed points are called foci. F1 and F2 are called foci of the hyperbola. Okay. Generally, we take 2 points here, A and B. These are known as vertices of the hyperbola. Here, A and B are called vertices of the hyperbola. Generally, we take coordinates of these vertices. Coordinates of A is minus A0 and coordinates of B is A0. And what will be coordinates of foci? Coordinates of foci, coordinates of F1 is minus C0, C0 is the coordinates of, minus C0 is coordinate of F1 and plus C0, because this is right side of the origin, so C0 is coordinates of another focus. So minus C0 and plus C0 are the coordinates of the foci F1 and F2 respectively. Also, coordinates of foci are F1 is minus C0 and another focus is F2, this is plus C0. X1x is called transverse axis of the hyperbola and y dash is called conjugate axis of this hyperbola. Here x dash x is transverse axis and y dash is conjugate axis of the hyperbola. Here length of transverse axis we take 2a. Here length of transverse axis, that is AB, is, their coordinates of A will be minus A0 and coordinates of B will be A0. So distance between AB is 2a, which is known as length of transverse axis. AB is 2a. And length of conjugate axis, somewhere C and D will be here. This will be 2b. And length of conjugate axis CD is 2b. Correct? So now this is very clear, very simple to understand what are different terms in the parabola. Now we'll discuss what is eccentricity of a parabola. Eccentricity of a cut. Now we'll see what is eccentricity of a hyperbola. Eccentricity of hyperbola is denoted by small e, and this value is c by a. So naturally OF2 is distance c and OB is distance a. So c is greater than a. So c by a, this ratio is always greater than a. This is c by a. And there is a relation between a, b and c. C square is equal to a square plus b square. This is the relation between length of semi-transverse axis A, length of semi-conjugate axis B, and distance of focus from the origin, which is C. So this is very useful formula. C square is equal to A square plus B square. Now let us understand what is latus rectum. Latus rectum of hyperbola. Latus rectum is a line segment perpendicular to transverse axis and passing through focus, maybe through F1 or F2 or both. Both will be same in length. So if you draw a perpendicular passing through F1, perpendicular on transverse axis like this, suppose you write PQ here, then PQ is called latus rectum. Correct? Similarly, if you draw perpendicular on x-axis, means transverse axis, on this point F2, which is focus, then this perpendicular, suppose you write LM here, LM is length of latus rectum. So here PQ and LM both are latus rectum which are perpendicular to the transverse axis and passing through focus and intersecting hyperbola at two distinct points, and this length is 2b square by a. So here latus rectum, here PQ and LM are latus rectum which are perpendicular on transverse axis, perpendicular on transverse axis, passing through the foci F1 and F2 respectively. Length of latus rectum is, we have to remember it, length of latus rectum 2b square by a, and here length of both the latus rectum will be of same length. Length of latus rectum is equal to 2b square by a. So these are very interesting and important facts, terms about the hyperbola, and we have to now discuss standard equation of hyperbola. Now here we are going to discuss about standard equation of hyperbola. When transverse axis of hyperbola is horizontal along the x-axis, then equation of hyperbola is x square by a square minus y square by b square is equal to 1, where a0 and minus a0 are coordinates of vertices, and the length of transverse axis is 2a. We are using a here. So what is a? Half of length of transverse axis. Similarly, b is half of length of conjugate axis. Okay. Now let us establish it. How we get this standard equation of the hyperbola? X square by a square minus y square by b square is equal to 1. Okay. In the beginning, introduction only, we have already discussed the definition of hyperbola, that the difference of the distance of P from two fixed points F1 and F2 is always constant. So we can write here Pf1 minus Pf2, and that constant distance we take equal to length of transverse axis 2a. Correct? Suppose we are taking here coordinates of point P. These coordinates are xy. Let coordinates of PB xy. So by distance formula, Pf1 is x plus c whole square plus y minus 0 whole square under radical sign. So Pf1 is, we can write, this is root over x plus c whole square plus c, because here point is minus c. So difference of x coordinates is square. So x minus of minus c is becoming plus c here, and y minus 0 whole square minus, similarly Pf2 will be x minus c whole square plus y minus 0 whole square is equal to 2a. Now we have to simplify it. We have to remove these radical signs. So we are transposing this term to right hand side. We'll get or root over x plus c whole square. This is y minus 0 is y. So y square is equal to root over x minus c whole square plus y square plus 2a. Now squaring both sides. In the left hand side, this radical sign will be removed and we are expanding x plus c whole square here. So this is x square plus c square plus 2cx plus y square. And in right hand side, if we square this binomial sum of two terms, we'll use formula x plus y whole square or a plus b whole square. So first term square plus second term square plus twice into product of these two terms. So when we make a square of this, radical sign will be removed. So we'll get here x square plus c square minus 2cx plus y square. And whole square of 2a is plus 4a square and plus twice ab. So 2 into 2a, that is 4a into root over x minus c whole square plus y square. Correct? Some of the terms will be cancelled out from left and right side. X square will be cancelled out, c square will be cancelled out, y square is also cancelled out. So we will keep this term in one side and the rest of the terms in another side. So 2cx minus 2cx will be transposed to this side. So we'll get here 2cx plus 2cx, 4cx, and this is plus 4, it becomes minus 4a square in left side, minus 4a square is equal to, in right hand side, we are getting square root of 4a into x minus c whole square plus y square. Here 4 is common in the left hand side, so this 4 will be cancelled out with this 4. So we will get here cx minus a square is equal to a into root over x minus c whole square plus y square, or squaring once again. So this is c square x square plus a to the power 4 minus 2a square cx is equal to, in right hand side, this is a square into this radical sign will be removed. So x square plus c square minus 2cx and plus y square. So we are getting here c square x square plus a to the power 4 minus 2a square cx in right hand side is equal to a square x square plus a square c square minus 2a square cx plus a square y square. Here 2a square cx will be cancelled out from both the sides. Now we'll keep terms with x and y in the left side and we'll transpose other terms to right hand side. So we are getting here c square x square, this has been transferred to left side, so minus a square x square, and we are transferring this a square y square to left side, so minus a square y square, and in right hand side we are getting a square c square minus a to the power 4, or from these two terms we can take x square common. So this is c square minus a square into x square minus a square y square is equal to, a square will be common from these two terms. So a square c square minus a square. Now dividing both sides by this much, a square into c square minus a square. So we will get here c square minus a square into x square divided by a square c square minus a square minus a square y square upon a square c square minus a square, and the right hand side is 1. Here c square minus a square will be cancelled out from numerator. Here a square is cancelled out. So we are getting here x square by a square minus y square by c square minus a square is taken as b square. So this is equal to b square is equal to 1, where c square minus a square is equal to b square. Correct? So this is the required equation of the hyperbola in standard form. X square by a square minus y square by b square is equal to 1. So this is the case when transverse axis is horizontal along x-axis, and if another case is if transverse axis is along y-axis, hyperbola is like this. In this case, this equation becomes y square by a square minus x square by b square is equal to 1. We should remember these two different cases. In this case, hyperbola is horizontal, transverse axis is horizontal. In this case, hyperbola is vertical, transverse axis is y-axis vertical. So basic difference is here x square by a square, here y square by a square. So I hope that this establishment of equation of hyperbola is very clear. We must understand it and hope you understood it. So remain in touch. We will see some problems from the exercise and share this video with your friends also. And if you are enjoying these videos, your likes are most welcome. Wish you all the best.